Today we're going to talk about managing imagery using mosaic datasets and image services. My name is Julia Lenhart. This is my colleague Abhilash, and we're going to talk about this with you guys today. So I'm sure you've seen this throughout the conference if you've been to a few different imagery sessions. When we talk about imagery in ArcGIS, we talk about 5 key capabilities. But today we're going to be talking exclusively about image management. And when we're talking about image management, we're talking about making imagery accessible. So we want to make sure that our customers, our colleagues, the public can access our imagery easily. And to do that, we're going to use mosaic datasets. In ArcGIS Pro or ArcMap, this is where you would create your mosaic datasets and manage those mosaic datasets. Using Image Server, you can publish your mosaic dataset onto the web as a web service. So today we're going to do a little intro, a little background, talk about managing imagery, sharing imagery, some best practices, and we'll wrap it up with some time at the end for questions. Before we get started, though, I just want to go over a bit of terminology that you'll hear throughout the presentation. Your raster format, that is simply the file extension of your raster files, right? It's just how you're storing your pixels, how you're choosing to store it in the specific file format that you're using. The raster type, on the other hand, is a little bit different. This defines how our software is able to read the metadata that gets cooked into your imagery. So a lot of different sensors come with information already cooked in, like the date that it was acquired or how it's best to display, the band information, things like that. All of that comes with the raster type. And so in ArcGIS Pro or ArcGIS in general, we're talking about setting the raster type as iconos so that our software knows to read your iconos imagery in a specific way, or something different, right? Any other kind of sensor type. The raster function is essentially an operation that gets applied to your raster dataset on the fly. It is, I think of it sort of like applying a filter to a photo before you're posting it on a social media platform. It's just adding a processing layer on top of your actual data without creating new data sets. And the mosaic dataset, this is the golden child of today's presentation. This is the primary information model for managing and storing imagery using ArcGIS. And the image service is basically just the mosaic dataset technology as a web service. Okay. So before we get started, I want to show you an example of how this can look when it's all set up and it's all done and you've used all these great things to share your imagery. Show of hands if you have seen the Living Atlas at this UC this week. Awesome, great. So the Living Atlas is this fantastic repository of GIS data that I wish we had when I was in grad school. And it is there, I mean, as you can see here, when I pull it up online, we're looking at just about 8,000 results of things that you can view in. Oh, that's not, okay. Let's do that, sure. So as you can see, there's all kinds of really good data here, and I can sort it by imagery. And there's all kinds of image services that either Esri has published through the Living Atlas or that other users around the world have published through Living Atlas. And so today we're going to look at the Sentinel-2 views. And so I'm going to open that on my, this is not going to work for me. So I'm just going to bring this back over and duplicate my displays. We're having this issue before. All right, can we see that now? Great. So I'll open this up and I can look at all of the really good information. The Sentinel-2 sensor is part of the Copernicus program in the EU. It collects data at 10, 20, and 60 meter resolution. It has a revisit rate of about 5 days. It's global, it's beautiful. It's great to look at if you're trying to explore a new area. So I can add this to a web map. I can also add it to ArcMap or to ArcGIS Pro. And what this is a mosaic dataset that has been published as an image service, right? And we've applied a little bit of processing on top of this. So it looks like a bunch of images that were stitched together, and that's our dynamic mosaicing. That's how that looks, right? It looks like they're actually being stitched together, but in fact, it's referencing individual rasters and displaying all of them at once. So let's zoom in on Madagascar, and if I wanted to take a couple different looks at this, I can use image display, and I'm going to use this renderer. And in ArcGIS Online, we call this a renderer. Throughout the rest of the session, we're referring to these as processing templates. And your Mosaic dataset can come with a whole bunch of processing templates that you can apply to it, which when I publish as an image service, it gets stored in the image service. So for example, if I want to pull out more information about imagery, I might say, let's look at the color infrared processing template or renderer, and then on the fly, just like that, all of my data gets processed, right? So this is an example of something that has already been published as an image service from a Mosaic dataset with a bunch of processing, and we're going to talk about how to make that happen. So, in ArcGIS in general, we support all different types of raster formats, all different extension types. We support a number of different data structural components, so the number of bands that you have, we support it, bit depth, whether you choose to have tiling or pyramids or things like that. We support multiple types of compression. ArcGIS can understand many different forms of georeferencing information, from coordinate systems to orientation angles. And it can read and understand a lot of metadata that comes with your imagery, but you can also add your own metadata as you want. So you've got all these different raster formats from many, many different sensors and all these different compression types. Well, how do you manage all of that? You do it using the Mosaic dataset. The Mosaic dataset is basically a catalog. It is a catalog that has an unbelievable amount of functionality attached to it. So the great thing about the Mosaic dataset is that it's actually just referencing the location of your source imagery. It's not copying and pasting your source imagery to a new location, which, as we all know, working with rasters, that can take up quite a bit of time and space. So it's actually just pointing to the location of your source imagery, and it's performing dynamic mosaicing. So it's making it look like they have all been stitched together into one big, beautiful image, when in fact it's simply displaying all of them at once. It can read the associated metadata with your source imagery. It can apply processing in addition to what is already there, so you can add an NDVI on top of your imagery if you want, or any other kind of index or processing. It's stored in a geodatabase, either a file or an enterprise geodatabase, and it gets created in either ArcMap or ArcGIS Pro. And it's highly scalable. You can have 4 images in a Mosaic dataset or 4 million. This is something that can be highly scaled in your single client machine or on the web. I like to think of it sort of like the drawer of scattered photos that I have at home that have not been organized in 10 years. And basically, the ability of the Mosaic dataset is to put this into a photo album for me without me ever having to physically move any of my photos. And so it's similar to just having a catalog or an index of sorts, but there's so much more that comes with it. I can apply processing, I can do selection and querying of my imagery, I can distribute it and share it as a web application, etc. So within the Mosaic dataset, we support all different kinds of raster sources. So it doesn't just have to be imagery. It can be thematic maps that have been classified. It can be LiDAR data or elevation data. All of these things can be stored in separate Mosaic datasets, or you can store them all together in one single Mosaic dataset if that's how you choose to manage your data. We support many sensor types, many different satellite types. You can import aerial imagery or drone imagery. And the dataset maintains image quality while also handling overlap and data that comes from multiple sources. So you can have Iconos data in there with Landsat, and you can also throw some elevation data in there. And it will handle all of these different sources, and it also handles times when your images overlap, which we see a lot with drone and aerial imagery, right? And finally, it supports image services. You can publish a Mosaic dataset as an image service if you have image server, or you can use image services as your input to your Mosaic dataset. You can create Mosaic datasets using geoprocessing tools. So you can go one by one through the toolboxes and run them, or all of the relevant geoprocessing tools have been put into the context menu for you. So anytime you right-click on something in Catalog and a menu pops up, that's a context menu. And we put a lot of thought into what goes in there. So everything that's in there is relevant to your workflow. If you know what geoprocessing tools you want to run in a row, you can string them all together in Model Builder, or you can use them in a Python script. And finally, if your primary purpose is to perform ortho rectification, then you can use the ortho mapping workspace in ArcGIS Pro to create a mosaic dataset. And if you don't know what I'm talking about, then you probably don't need to do that, so don't even worry about it. So this is sort of the bare bones workflow that we recommend you follow for creating a mosaic dataset, right? First, you create or identify the geodatabase you need to create your mosaic dataset. Then you create an empty mosaic dataset. And finally, you populate that mosaic dataset with rasters to create a populated mosaic dataset. And optionally, you can generate overviews, which we'll talk about here in a second. So when I'm adding rasters to a mosaic dataset, I'm using a geoprocessing tool, just like every other step along the way. And the important thing to note about the Add Rasters tool is that you can specify certain parameters, and especially you can specify the raster type. So what the raster type is as we talked about, this is what tells our software how to read the metadata of your input data. And so once you set your raster type, it will know which file extensions to crawl for, to look for in your folder, so that it only pulls in those file extensions to your mosaic dataset. It also defines the initial processing. So you can tell it, I only want to look at panchromatic views of my imagery. So it will apply that processing to your mosaic dataset right off the bat. And when we talk about overviews, we're sort of talking about pyramids, but for the mosaic dataset. So I was in tech support for a while before I moved into the role I'm in now. I'm a product engineer on the development team for raster. And one of the number one questions we got for mosaic datasets is, why can't I see my data, right? Either when I'm zoomed way in or when I'm zoomed way out. So when you're zoomed way out and you cannot see your mosaic dataset, it's because you have not generated overviews. And overviews are basically snapshots of the big picture when you're looking at all of the data. So if you have hundreds of thousands of images and you haven't generated overviews, it would take a really long time to display all of them quickly, right? We would want it to be quick when you're zoomed way out. So that's why we recommend generating overviews, so that when you're looking at your entire mosaic dataset, it comes up really quickly. So let's take a look at how this goes in ArcGIS Pro. So this is sort of the finished product that we're talking about today. This is what your mosaic dataset looks like in the end. We have these green boundaries that show us the outline of the individual images. The blue boundaries are seam lines, which we'll talk about in a little bit. And we're just going to go through the process of creating it from A to Z. So I'll open up my catalog, and I've got this empty mosaic, or my empty geodatabase, which I'm going to add a new mosaic dataset to. So I'll go to New and select Mosaic Dataset. And my Create Mosaic Dataset geoprocessing tool opens. And this is where I can give it a name. So we'll call this Sentinel UC Demo. And I'm going to set the product definition here to Sentinel-2. So I'm already telling it ahead of time, hey, I'm going to be working with Sentinel-2 data. And you'll notice that in my product properties, my bands have already been populated. It already knows what type of wavelengths I'm working with Sentinel. If I change this to Landsat, it will change the band information. So it knows what to look for already. So I'll go ahead and click Run. And all this is doing is generating an empty mosaic dataset. And it's going to add that empty mosaic dataset to my map. Of course, it won't display anything because I haven't told it what rasters belong there yet. So back in Catalog, I can right-click on my mosaic dataset, and my Add Rasters tool is right here in the context menu. And it's already populated my raster type with Sentinel-2 because I already told it, hey, this is what I'm going to be using this for. Now, if I wanted to use this mosaic dataset for many different sensor types, I would not have set the product definition beforehand. I could set my Sentinel-2 type here instead. So it's asking, where's your data? And I'll show you just in Windows Explorer, this is what my data looks like. I have this imagery folder that has a ton of different folders inside of it, that also has folders inside of it. And even as a regular user, I might not even necessarily know which one of these folders contains my actual imagery. But thankfully, I don't have to know that because the software already understands that. So I will browse to that location. And you can see that under the advanced input data options, it's telling me which data filters it's going to look for. And it's already including subfolders. So I'll click run. And it's just crawling through that folder to find all of those image types that match the extension that it's looking for. And what we're going to end up with is about 8 images added to my Mosaic dataset. I believe it's 4 tiled images across 2 different timestamps. So one from 2017, one from 2018. And when it displays, I'll be able to see everything, but I did not choose to estimate statistics. So when I don't estimate statistics on my Mosaic dataset, I sometimes have a hard time seeing what I'm actually supposed to be looking at. So my first go-to is to always go to the Appearance tab and hit DRA, which stands for Dynamic Range Adjustment. I would not have to do that if I calculated statistics on this. But for the sake of time, I don't want to have you sit through waiting for that tool to run. But here's my data. I'm looking at the Salton Sea. I've got 4 images mosaicked, and then there's actually 2 layers of them, one on top of the other. And what I can do from here is I can actually take a look at the footprint table. And this is the table that tells me all my imagery that's in here. And so it has taken in all of this really good information that was already cooked into my imagery, like acquisition date, cloud cover, the sensing orbit, things like that. Okay. And what I would do next is generate overviews on top of this so that if you'll notice, when I zoom out to a certain extent, it just disappears. If I had generated overviews, I would always see a snapshot of what my imagery looks like. So in addition to this basics workflow, you can do a whole bunch of other really fun stuff. So if you want to get really specific about the type of data that you're working with, if it's not just about display, if it's about analysis and things like that, there are a whole list of other operations that you can perform. And we'll talk about why you might want to do some of these things. So for example, here is Iconos data over Portland, Oregon. And this might be just fine for my purposes, but if you'll notice in the edges of some of these images, we have these strips of no data. So maybe we want to get rid of these. Maybe we want to shrink the size of our building, of our footprints, the green boxes, to eliminate those areas, or simply tell our Mosaic dataset, hey, this is no data, right? And for that, I would use the Build Footprints tool. You can set your minimum and maximum valid pixel numbers so that it will only accept those values and it will display the rest as no data. You can also use the shrink distance here to shrink your boundary footprint by just a little bit. Alternatively, you might notice that maybe these images were collected on different days, or different stretching types were applied to them, but we have a little bit of a color imbalance happening here, right? And so for that, maybe I would run my color balance tool and my build seam lines tool. The build seam lines tool is the one that actually blends pixel values across your image. And again, none of this is modifying your source data at all. It is simply making changes to the way that this is displayed and being accessed on your project. One of the other really great things about Mosaic datasets is that you can attach processing to the Mosaic dataset. So the initial raster function chain for a Mosaic dataset is defined by your raster type, but I can apply additional processing on top of that. I can run raster functions on individual items in my Mosaic dataset. I can attach a raster function to the end of the chain for my entire Mosaic dataset, which that basically modifies the dataset kind of permanently. Again, not your source data, just the Mosaic dataset. But today we're going to talk about attaching a Mosaic dataset or attaching a raster function chain to a Mosaic dataset. So in this case, I'm going to zoom way in here. What we are going to do is, let's say I'm interested in getting an understanding of the distribution of water in my scene, right? So For that, I want to use a raster function, which is just applying on-the-fly processing. So I'm going to use the band arithmetic function. This is my go-to for pretty much any index that I want to calculate. I'm going to set my method to NDWI. And this is the normalized difference water index. And for Sentinel-2 data, so what it's asking me for is what is the band number for near infrared and what is the band number for green, for your green band. I know for Sentinel-2, I think it's 8 and 3. So we're going to hope for the best and say that's right. So I could just create a new layer here, but I'm going to save this as a new function. I'm going to call it NDWI Sentinel. And I'll just save this raster function to my project and click OK. And that populates this function in my project tab here, NDWI Sentinel, and I can open that up and it has saved all my settings. Now, if I want to apply this I want to attach it to my Mosaic dataset so that I can access it whenever I want to with my Mosaic dataset. I don't have to recreate it every time I'm looking at this. So in my catalog, I right-click on my brand new Mosaic dataset and I will say Manage Processing Templates. And this brings up this pane that allows me to import or add additional processing templates to my Mosaic dataset. I'm going to import that. Go to my raster functions group here. I saved it in my project. So here's my NDWI Sentinel raster function template. Click OK. And now it's part of my template. So what that means is that when I select my Mosaic dataset, my contextual ribbon at the top here, the Mosaic layer ribbon, has this list of processing templates I can choose from, and one of them is NDWI. Now again, you'll notice that my screen went black, and again, if I had estimated statistics on my Mosaic dataset, you would not see that happening. So it just means that anytime you're adding new processing to your Mosaic dataset, it's kind of regenerating an estimate of statistics. If I calculate the actual statistics, it works just great. But if I'm allowing it to estimate statistics, what it does for the Mosaic dataset is it takes the center 1,000 by 1,000 pixels and uses that as a proxy for your statistics. And it just so happens that the center of this dataset is the middle of the Salton Sea, which would show up very, very dark. And so the result is a very dark output. But what I can do is I can select this NDWI Sentinel as my processing template that I want to show. And it's just applying that raster function that I just created on the fly to my Mosaic dataset. I'll let that load here. And so now I have an understanding of how water is distributed throughout my scene. This has not changed my source data. It hasn't touched anything other than adding a processing template to my Mosaic dataset. And I can carry this along with me when I publish it as an image service to the cloud. So I will go ahead and pass this on to Abhilash, I believe. Yep.
Good afternoon, everyone, and thank you, Julia. I'll be talking about sharing imagery using ArcGIS. So one of the main components of the sharing story with ArcGIS is the ArcGIS image server. ArcGIS image server is part of the ArcGIS enterprise, and it provides a distributed computing and storage system that can allow you to analyze and serve large collection of imagery data. It allows you to assemble, process, analyze, and manage large collection of multi-resolution overlapping images, which was collected over a period of time using different sensors and collected from different sources. So there are 4 key capabilities with ArcGIS image server. The first one being that it allows you to create dynamic image services. Image services are web-enabled imagery layers, and dynamic image services are those which allow you to process data on the fly as the data is being accessed. You can perform a variety of analysis on these data, and you can consume it through desktop, mobile, or web applications. ArcGIS image server is also a core component of raster analytics. Raster analytics is nothing but a set of services on the server which takes advantage of the distributed computing and storage capabilities of the server. it allows you to apply a rich set of tools and functions which can be applied onto a large collection of images, and then you can create persisted output which can then be shared across your organization. It also allows you to do orthomapping by processing satellite, aerial, and drone imagery to create digital elevation models and orthomosaics by using the server-side capabilities. You can also upload imagery into ArcGIS Enterprise and serve it as dynamic imagery layers. The hosting server allows you to publish hosted layers, which can then be used as input for analysis on the web or on ArcGIS Pro. So we took a look at the image server. Let's take a look at what is an image service. Image service is a primary information model for imagery on the web. It's nothing but a raster data that has been shared using an ArcGIS server. The data can then be accessed using a web service. The data can be a single data set on a file or a geodatabase, or it could be a collection of images that's been managed using a Mosaic dataset. The benefits of using the image service is that it allows you to put imagery into use quickly. You could have a large collection of images, you can create a Mosaic dataset with it, and you can share it with other stakeholders by creating an image service. They can then quickly use that input and do their analysis on their end using all the platforms that are available. It also allows you to view multiple views of the imagery, original imagery. So you can change your mosaicing method and view the data according to your requirement. For example, let's take an image service of an area which has collected data from over a year. And if the underlying data set has been classified with images from summer, winter, autumn, and spring, then the user can change their mosaicing method and view the data according to those seasons. You can also access the catalog of the imagery of the Mosaic dataset, of the underlying Mosaic dataset. And what that means is you can perform query and you can see the data in the light of the results of those queries. For example, you have a Landsat Mosaic dataset, you publish it as an image service. You can perform a query on the cloud coverage and get back the results of that and view it. You can also perform on-the-fly image processing. That is, you can attach a raster function while you're publishing the data, and the end user can then apply that and do their analysis. And also, image services can be time aware, which means you can visualize and explore temporal changes with your data. Now, how to publish an image service from ArcGIS Pro? In order to publish image service from ArcGIS Pro, you must invoke the publishing wizard from the catalog pane and not from the content pane. So once that comes up, it allows you to configure how you want the end user to interact with your imagery layer. There are a lot of options that are available in your publishing wizard. You can choose whether you want to publish your data by reference or by value. You can define processing templates which the end user can then apply on your service. You can choose whether to allow the users to download image from your service or enable them to use mensuration with it. Also, you can enable WMS and WCS capabilities on your service. These are nothing but other type of services with international specification that was defined by the Open Geospatial Consortium. This is a quick overview of how you would publish your data from ArcGIS Pro to your portal. So you first invoke the publishing wizard from the catalog window from the context menu of your dataset. You click on Share as Web Layer. That brings up the publishing wizard. And then once you have defined the basic details, you can go to the configuration window and choose your options and then hit Publish. From ArcGIS 2.4 onwards, users can now publish data into a standalone server. A standalone server is a server which is not federated or linked to a portal. So the workflow over here is slightly different in the sense that you need to first create a connection to your server. From the context menu of that connection, you can bring up the Publish option, and then you choose your data and publish it. One of the caveats with this method is that currently it is only supported publishing to a ArcGIS version, a server version 10.6 and above. While talking about the different options with publishing image services, I had spoken about sharing by reference and sharing by value. So these are nothing but options as to how or where you want the underlying data to be located in reference with the image server. So if you choose to share by value, the data will get copied to your server. It will make the access to the data faster, but it is only feasible for services for data sets which are of smaller size or lesser number of images. It is not recommended for large imagery collection because it has an additional overhead of time where it takes to copy the data across, and it requires additional storage to store these data set on the server side. So the other option is to share by reference. In this case, the data is accessed from a location that is registered with the server. And in this case, the data does not get copied because the servers can directly access the data from here. Since it's not getting moved, this is a recommended method to publish your dataset of larger image collections, or even if it's a single dataset which is of a large file size. Now we can take a quick look at how this can be done from Pro. One second. So in order to publish from Pro into ArcGIS portal, you need to make sure that you're first signed into your portal. So over here, you have the option, if you're not signed in, you can go to Manage Portals, add a portal, and sign in from here. Once the sign-in is done, and you go to your dataset which you want to publish, you right-click on it. It'll show the Share as Web Layer option. You can click on it, bring it up, give a basic information about your service over here. And over here you have the two options to whether you want to publish the data by reference or you want to copy the data. So in this case, I'll choose reference, and I'll go to the configuration window, Imagery. And here are the options whether you want to allow users to download the images or you want them to allow do mensuration on it. Also, there are other options like what do you want to set as your default resampling method? Do you want to allow compression? And here you can input the raster functions which you want the users to work with. I'll add the same NDWI raster function which Julia had created. And also, if you want the users to perform mensuration, you can add your elevation source if needed. And once that is done, you can click Publish. You can first analyze the data and see if there's any warning or error messages with it. So I had chosen to publish the data by reference. But if the server is not able to access the location when you do an analysis, it'll show up over here. So you have to make sure that the data can be accessed. Otherwise, even if you click publish, it's not going to do it by reference. It's going to still copy the data across. Since I've already registered it, I don't get that error message. If it comes up, you can always right click on it and it'll bring up a UI where you can set the proper path to your data and register the store. And you hit publish and it gets added as a portal item, which you can access from your catalog window. Go to portal, my content, and I had published it to the demo folder. So this is where the published item comes about. I can add it to my current map. And this is the final image service. You can access the same thing from your portal as well, from the web. You can change the appearance, and you can also apply a processing template which was published along with it. Take a little time. Still doing it. Okay, I'll just let it do its thing. I'll go back to the slide. Okay, it's done. And I can hit DRE so that it shows up. Now, you can also share imagery from portal for ArcGIS. In order to do that, you can create imagery layers from portal that can be then shared with your organization. The imagery layers can be created using raster types which are supported on portal, and then it is written down to a raster store and published as image services from there. In order to do that, you need to first add a data store. There are three types which are supported. The first one is a folder, second is a database, and third is a cloud connection. And once that is done, it takes you to a configuration page where it allows you to set the path to your location for the data. In this case, it's a cloud storage which was selected, and you can provide all the access key and the information to connect to it. Once that is done, it takes you to a validation page where it checks if the server has access to the data. Once it's validated, you can add the data store. After the data store is configured, you can create the imagery layer. Over here, you have an option to choose how you want to deliver the data into the imagery layer. So there are three ways you can do it. First one is it creates an imagery layer that contains all the images as a mosaic dataset which is published. Second one, it takes all the input images and creates a single CRF file and it's published. And the third method, it creates multiple imagery layers, one for each of the input in your data store. So for example, if you have 10 images in your data store, the first one creates a mosaic dataset out of it and then publishes that. The second one, it mosaics it into a CRF file and publishes it. And third one, it creates 10 different imagery layers, one for each of the input in your data store. And just like Julia mentioned, while creating and adding raster datasets into a mosaic dataset, here also input raster types are supported. And each raster type has a unique metadata that is specific for different sensors and image collection parameters. So you need to choose the right raster type for your dataset so that the image gets displayed properly and the images are consistently processed. Once the dataset imagery layer is created, it gets added to your portal and you can access it from your portal content page. Let's take a quick look at that as well. So this is my portal content page. In order to first add a data store, I go to add item, data store, I give it a title. In my case, my data is in a folder. I select the folder. Click next. It takes me to the page where I can configure the connection. Over here, I'm supposed to give the path to my data. I can give the path over here and click next. It will validate. My data store is already configured, so I don't have to wait for this. So clicking add data store will register it. If there's an error, you might have to make sure that the server has access to that folder. Then you go to create, select imagery layer. And these are three options. In my case, I'm going to be creating a collection of all the input as a mosaic dataset, so I'll create this one. My raster type is Sentinel data. And from the properties page, I can choose what processing template to be applied, so I'll select only the multispectral ones to be selected. Click apply. I can choose from my data store which is configured, select that, click next, and it will ask you for the name and tags for your final imagery collection. One important thing over here is you can also add data from your local store without registering a data store. This is similar to sharing by value. And in this case, when you browse and select your images, these get copied to your raster store. It's going to take additional time and then get published from there. Once the imagery layer is published, you can go to your portal content and you can see the item inside. Select it, And you can either open in a map viewer or through portal, you can select the same item and use it. So this is how it'll look once it's done. You can add it to your web map viewer. So we can also access imagery in the cloud through ArcGIS Pro. Nowadays, it's quite common to store all your images on the cloud. And in ArcGIS Pro, you can access it by creating a cloud storage connection. There are 4 different service providers which are currently supported. They are Azure, Amazon Web Services, Google Cloud, and Alibaba Object Services, Storage Services, sorry. And in order to access these images, you need to first create a cloud connection file. You can use the Create Cloud Connection, Cloud Storage Connection GP tool to create that file. You'll need to give the file name, service provider name, access from here, and the bucket name and other security related information. Once that is done, you can access the data through a catalog, just like accessing a regular folder. Where did it go? Oh, sorry. And another aspect of publishing workflow that needs to be mentioned is image service caching. Caching is nothing but creating a pre-processed, pre-generated set of tiles so that the server does not have to access the input mosaic dataset or raster dataset each time a request is sent. The advantage of this is that it improves the performance of the service in client application, but there are a few things that you need to keep in mind. One is that it takes a long time to generate these tiles, and it requires additional storage on for storing these pre-generated tiles. Also, each time the underlying dataset is updated, the cache also will have to be updated. So this is the overview of how it's done. Similar to publishing the image service, you can bring it up from the this time from the content pane, share as web layer, and make sure you select tile as the layer type. And in the configuration window, you can select the level of details you need and the type of caching you will require. And you can hit publish, and it publishes the tile layer. You can also bring the same wizard from the share tab in your ribbon. And that will also bring up the publishing wizard for tile cache. And with that, I would like to ask Julia to talk about the best practices for managing imagery data.
Okay, thanks, Abhilash. So best practices. I would love to give you all of the best practices for all of the different data types, but of course, as we all probably know, best practices are data specific. It depends on where your data is coming from. It depends on what you want to do with this data. So the number one thing that I always recommend if you're looking for best practices is to go to our Imagery Workflows website. This website is developed by our product management team. It has a collection of all kinds of really good resources broken up by the type of data that you actually want to work with. So it'll have a best practices for elevation, best practices for LiDAR, best practices for drone imagery, and so on. We can tell you a couple things just about storing imagery. We recommend to store each collection of images in a separate directory and try to limit that to about 1,000 files per folder so that when you're consuming them in your Mosaic dataset, it doesn't take quite as long and it's not having to search through a ton more files than that, right? We recommend 1 Mosaic dataset per geodatabase or at least just a few. So try not to store 10, 20 Mosaic datasets in a single geodatabase. Most of the time your metadata is going to be stored with your imagery anyway, but if for whatever reason it comes separate for you, we recommend trying to keep that in the same directory. And for your own sanity, try to keep a consistent naming convention, just for organizational purposes. When it comes to pre-processing your data, we recommend building pyramids on your source rasters before consuming them in a Mosaic dataset. Just allows for faster processing and display. Make sure that you're familiar with your data. Identify what your node data values are. Make sure that you know what your units of measurement are. And I should add one more thing here. Make sure you know what your coordinate system is. So if your data is showing up in the middle of the Atlantic Ocean, it's probably something to do with your coordinate system. And if you've ever called tech support and talked to our projections whiz Margaret, she will help walk you through that. So when it comes to creating and improving your Mosaic datasets, default values are your friends. 99% of the time that I'm running our tools, I'm just keeping our default values. We think of them carefully, we choose them carefully when we put them in. Make sure you set your product type and your raster type so that the metadata actually gets read properly. And use a mask or the build footprints tool to clip your data. So if you want to shrink your data in, if you want to get rid of no data values, you can use the build footprints tool with the radiometry option and a shrink distance. And use the seam lens tool to blend colors across your images when necessary. When it comes to publishing image services, like this is sort of reiterating, we recommend you publish when you're publishing, we recommend you use the share by reference method. That means registering a data store, so you're not copying your data over to the server, especially with big data sets, right? If you only have a few images, it might be just fine to copy everything over, but this is what we recommend. We recommend caching your imagery when the services are going to serve as base maps. So generate a couple levels of tile caches so that when you're zooming in and out, it appears more seamless. And we also suggest to cache services that were published with low performing or highly compressed formats. So just to summarize what we talked about today, we talked about Mosaic Datasets, which is the primary information model to manage imagery. It supports dynamic mosaicing and on-the-fly processing. You can do a ton of modification to fit your data needs, and it can be accessed across the platform in Pro, ArcGIS Online, and in Portal. Use ArcGIS Image Server for dynamic image services. I will just say that if you just need a base map, you can just use tile images and you do not need Image Server for that. But if you want to use image services, you're going to have to use the Image Server. You can also access data that is stored on the cloud. You can store your raster datasets in a cloud environment and also access it from ArcGIS Pro. And always check out the best practices. Look up the documentation that we have. Take a look at what other people have seen and some of the things we've had there. So we will take questions, but I will say if you liked this session, please share your feedback in a survey. If we didn't cover something that you wish we had covered, put that in the survey. If you want something a little bit different next time you're here, put it in the survey. We want to know what you guys want to see. So, but for now, we are happy. We've got about 15 minutes left. We're happy to take questions. Yep.
What's the advantages and disadvantages of the first two options of publishing from Portal? The one that was a collection is basically just a Mosaic dataset versus the second.
So the question is, what are the pros and cons of publishing from Portal, either as a collection of images, the Mosaic dataset, or as a mosaicked image, one big image?
So the only difference is that the first one, when you create it as a Mosaic dataset, it has all the data as you have the catalog information in it. So if you want to do query and all, it'll be advantageous from that way. The other one, it's a cached format, so it'll be easier. The viewing of the images will be faster. So the data format supports quicker access of images, and it's a little more better performance.
Would processing templates be still in that second version?
In Portal, when you publish, it doesn't take processing templates in it. But you can do analysis on it separately.
Got someone here? Yep.
Yeah, I was curious if the data that you find, like on the image server or in Portal itself, if there was a way to take that data and add it to a Mosaic dataset so then you could use it offline if you need to, or does it not work that way?
So the question is, how can you use image services in a Mosaic dataset? It still would require you to have a connection to that server. It simply means that when you're populating your Mosaic dataset, you can add 10 different image services to the same Mosaic dataset so that I can manage them all or visualize them all in one dataset and be able to query each of them. But it requires you to have all the same permissions to the data and a network connection, or at least a connection to that portal.
So there's no way to publish from Portal to ArcGIS
Like download, you mean?
Yeah.
So if you provide download capabilities.
Yes.
Yes. So if the image service has been checked on for, yes, I want my users to be able to download, then you can download from an image service directly. You'll find that with our Living Atlas services, many of them allow downloading up to a certain size. So you can only do 2,000 by 2,000 columns or something like that.
But if you just want to access those data, you can always connect to that image service and use it in Pro, unless if it's just about accessing it in Pro.
Well, I can't use it. I would have to download it and move it to a different computer.
Okay,
Gotcha.
offline. Okay.
Over here.
Just before getting the bottom to file cache and process it, would it be possible in the analysis to have an estimation of how much time it would take according to our machine configuration?
Yes.
Sometimes we don't know if it will take 3 hours or 3 weeks.
Yep.
It would be fun to have an estimation.
I agree with you. Yes, and we've asked that question. That comes, not just in this particular workflow, but also, okay, when I'm running this tool, how long is this going to take? When I'm going to be adding this imagery in, how long is this going to take? Unfortunately, the amount of the calculation that would have to go into how much RAM do you have, how much, what's going on in your specific machine, and also are you connected to a cloud environment which maybe extends that? It's likely a little bit too difficult to actually provide even a guesstimation of how long it would take. The best we do is we try to make that progress bar as accurate as possible, but unfortunately, the answer is no, we don't have that ability, and it is likely not in the roadmap. Yeah. Yeah.
You said to make sure that the coordinate systems are, make sure that you're aware of what they are, but how would you compile multiple different coordinate systems into a single mosaic?
Right, so as long as your coordinate systems on your raster datasets, the sources themselves are correct, I can set my mosaic dataset to any coordinate system I want, and it will project them on the fly. So if my original source data has the wrong coordinate system set, nothing's going to fix that. I have to make sure I go in and actually set the correct coordinate system. But if I have all of my stuff in Web Mercator and I want it to be projected to a specific state plane coordinate system, I would set it in my mosaic dataset and it would reproject all my input on the fly. Yep.
So do you have like 30 different, year sets of imagery, and you're doing it in server? Would you recommend putting all of those into one mosaic data set, or you said you only put one mosaic data set
Per geodatabase.
And so, or would you just do a separate enterprise geodatabase for every single year?
It totally depends. Some of us, if we're doing temporal analysis, for example, we would want all of that time information in one big, beautiful mosaic data set. It depends. And so if really what you're interested in is cataloging your data so that it's year by year, or maybe you're more interested in cataloging it by space. So I only want my Sentinel or my Salton Sea data in one, and then I want all of my other desert data to be in a different one. So it completely depends on you. But having all of your different timestamps in one single mosaic data set, that's done a lot. So it allows you to visualize how things have changed over time. You can run raster functions on top of your mosaic data set that can look at the difference between some of those. So
Even if they're different, like say projections and...
yeah, and you could also choose to have one data set that's all of your drone data through time, and then one that's all of your satellite data through time. So if you have multiple sensors or multiple coordinate systems, you could save those separately or all in one go. It totally depends on what kind of information you're trying to keep track of in your mosaic data set. If it's strictly just to keep everything in one place that I can query whatever I want, throw all your data in there, and then you can be able to pull that out one at a time. Yep.
Individual, like full metadata for individual rasters, say like you have scan maps, you're putting them all in one mosaic data set, you have full GDC metadata for each of those. I know in the metadata, the mosaic data set as a whole, you can have metadata for the mosaic data set, you can access that as an image service. But how does that accessing the full metadata for each raster in the Mosaic Dataset or image service to get access. I assume you can get to it somehow.
How does it get read?
Yeah, I mean, well, it's inside the TIFF.
Right.
You know, let's just assume it's a TIFF.
Yep.
But then when you're looking at it as an image service, and I want to see the full metadata for that particular file, not the Mosaic Dataset as a whole,
Gotcha.
is that something that's available?
Right, so once it's in an image service, how do you access all that good attribute information for each of your raster inputs?
Not so much the attribute, you can do that through the table, but
Right.
the actual
The metadata
like
itself.
item description kind of stuff. Is that possible?
So basically like this,
Okay.
you can explore the raster items. Is this what you want?
So this is, the Explorer Raster Items, or the Raster Item Explorer tool is phenomenal. It allows you to query your data according to certain fields or certain things and actually browse through each individual slice of your Mosaic dataset and look at all of the data that comes with it. So this is all the stuff that would be in the properties of your,
I guess I'm talking more like if you have a scan map and you imported GDC metadata to that
Gotcha.
scan map of, say, a geologic map. Now I got all kinds of them in a Mosaic dataset. We have that, but we're having a hard time figuring out how to get to the full metadata of each one.
I would think that that would be in the same space, but that's a good question, and I would want to look at that because I haven't actually messed around with scanned maps too much.
It's a
So,
whole other set of problems.
yeah, I can imagine.
So it comes up in the Mosaic dataset, but when you publish it, doesn't you're not able to access, or?
We're not, I don't even know if it comes up in Mosaic dataset. Just
Right.
because
Okay,
of the-
okay.
You know, you can do
Yeah.
all kinds of stuff, and we have attributes, and we're doing all kinds of wonderful things, but then others have said, hey, but I want to go back to that original metadata for that scanned product.
Right.
And I haven't been able to answer that.
Okay.
That's a good question. We can take a look at that and maybe get your information and. Yep.
Are there mosaic datasets in ArcMap versus in ArcPro?
Also in ArcMap. Yep.
Can I add on to that?
Yes.
Make sure that if you're doing this in Pro, that all of your users are on a different, because we did it and everybody's on Arc 10.3, and I did all of my Mosaic datasets in Pro, version of Pro, and nobody could see any of my Mosaic datasets because it wasn't there.
Yes, and we recently fixed that so that for 2.4, I believe 2.3 is now compatible with 10.6 and 2.4 is with 10.7 and 10.6. And so we're trying to make them, it's not exactly backwards compatible, but we want to make sure that they are at least equivalently able to see some of those things. But yes, that's a very good point.
Why would you limit one mosaic dataset to geodatabase?
Mostly for management purposes, and for file geodatabases, you're going to be limited. You're going to hit an upward limit when it comes to performance because it's just sitting on your machine.
What is a performance issue?
It could be a performance issue, yeah. If you're looking at an enterprise geodatabase environment, you might have a little bit more wiggle room. Maybe you could manage a couple more Mosaic datasets because you have, say, a system that is distributed across multiple machines or something like that. But with the file geodatabase, I mean, inevitably, at some point, if you're storing a ton of data in a file geodatabase, that is simply a folder structure on your machine. So you're going to run into some kind of performance issues. Yeah. Yeah.
How do you generate overviews?
Generate overviews using that's a great question. Am I on? No. So you use the Generate Overviews tool, and that comes in the context menu. It's also all available through the toolbox. I could have done this right off the bat when I go to add rasters. And notice you can add rasters many, many times to the same Mosaic dataset. That's how I would continue to add different sensor types, right? But here in the post-processing, I can choose to update overviews. I can also do this after the fact by right-clicking on my Mosaic dataset and saying optimize and build overviews. The define overviews tool is a little bit different. This lets me kind of pick and choose what types of, maybe where in my data set I want to create overviews. Maybe I just want it for one area. Maybe I want it for certain, I want to force the overview tiles, or I want to do a certain number of levels or something like that. But the actual build overviews tool in the context pane comes from optimize, build overviews, and this is where I would set my parameters. Usually I just leave everything as is and hit run. But if you've already generated overviews and then you added a bunch more data, you might only need to generate missing overviews, right? Or regenerate stale overviews if you deleted a bunch of source rasters from your Mosaic dataset. Yeah?
Back from when I was first doing all of this, I had to go in and define the overviews because my data, the overviews generated on the computer that I was on.
Yep.
And not on the server.
Yes.
Is that still a thing? Or
It's still on the.
If you were to generate them with your image, well, like if your data was stored on the server and when you hit
data
generate
was stored on the server,
Yeah.
I built my overviews
in Pro or in ArcMap.
in ArcMap.
Yeah.
This was back.
Yes.
And then all of the overviews were built on my C drive on my computer
Yes.
on my desk.
I'm not sure if that's still a problem. I would guess that it is still happening, but I would need to test that.
But you
Okay.
can always choose where to create, right? In your build overviews.
Let's see. Can you choose? Yeah, you can choose where. Well, you have to use define, and then you can choose where the output is. But yes, running build would just automatically do it on your machine. Yeah, you're right. Okay, we are out of time, but we will be down at the Imagery Island, and yep.
How much faster is Pro generating the Mosaic datasets than ArcGIS? Is there performance difference?
I don't think I'm supposed to say. No, I don't know. That's a great question. I would imagine it's very similar. It's just like layer files. You're just pointing to the source location and consuming it back in. I think it's pretty on par. Yeah. All right, thank you guys so much. Have a great rest of your UC. Thank you.
Thanks, guys.